Hi guys, my name is Prabhakar TP and welcome to Crimson Sky. Today we'll be talking about hydraulic systems of an A320. It is one of the easiest system to understand and learn. Doesn't have a lot of complicated connections or anything. It's pretty straightforward. So in this lesson today we will discuss the basic working of the hydraulic system. What are the components and how does it work in general? And then we'll talk about the normal operations. So generally the hydraulic system is fully automated. You don't really have to interact with the system much because the system is totally independent and it can work on its own. But in a day-to-day life, we might have to operate certain switches or certain systems when the situation demands. So we'll talk about some examples so you get an idea about the practical application side of the things. And then we'll talk about some abnormals. So hydraulic systems, if it fails, it can create a lot of problems, and God forbid, and also for your type rating. And God forbid, in your line flying, something like this happens. We will look into certain instances, small failures, and then one major failure, and see how do we go about it. Just the basics, so that you can understand and appreciate the system redundancies, and be better prepared for such abnormalities should it ever come across in your life. Hopefully not. And then we'll review and recap the entire thing that we learned. Alright, so that is how the lesson plan will be focused like today. We will not be covering the entire thing in this lecture. This lecture we will be focusing on the basic operation, then we'll talk about the normal operations, and then we'll call it a day. And then on the part 2 of this video we will talk about the abnormals part of things. So let's start with a very famous quote and one of my favorite quotes. Once you have tasted flight, you will forever walk the earth with your eyes turned skyward. This is by Leonardo da Vinci. We all know who he is. Pretty much sure that all of you guys who are now CPL rated can very much relate to this saying as much as I can. So let's, this one quote, just being it there because it's something that is very, very close to me. So I just shared it there. Alright, without wasting much time, let's talk about the operation part of this. So like I said, the hydraulic system of an A320 is pretty much automatic. You don't really have to deal with much things. So in general, in a hydraulic system, there are 3 systems. There is a green system, there is a blue system, and then there is a yellow system. It is not color coded in any way. When I say green, blue, yellow, it's just for the understanding so that it's easy to relate. So that is why Airbus have color coded the system, but like I said, the fluids are not colored or parts are not colored or anything as such. So let's talk about the green system first. Alright, the green system is controlled by the left side engine, which is the engine 1. So first of all, the hydraulic fluid works. So basically the hydraulic systems are used to operate machineries, right? Flaps, landing gears. We'll talk about the application side later. But the basic principle is Pascal's law, and the requirement for a hydraulic system is to operate heavy machineries with the forces that we have available with us, correct? So hydraulic fluid is an incompressible fluid which works on Pascal law. If you don't know what Pascal law is, please go back to your physics, Google about it. It's pretty much straightforward, you will understand it. So basically we have hydraulic fluid stored in a tank, and this tank is called a reservoir. So the green hydraulic system fluid is stored in a green reservoir, and this tank needs to be pressurized. If you want the fluid to work function properly, you need to store it in pressure. So this pressure, how do we pressurize a tank? How do we keep this fluid stored in a pressurized tank? So we have the left engine, which is called engine 1. So from henceforth, the left engine I'll be always be referring to as engine 1, which is the port side, and the starboard side, which will be called engine 2. So the engine 1 creates bleed pressure. This bleed pressure is basically a conditioned pressurized air that is generated by the engine. The high pressure air is called HP. There is intermediate pressure and then there is high pressure. There are 2 types of bleed pressure that is developed by an engine, but we'll talk about pneumatics in another chapter. So this high pressure air from the engine is sent into this tank, and then this tank is pressurized by that air. Okay. All hydraulic fluids are stored in their own corresponding reservoirs. Green has its reservoir, the blue has its reservoir, the yellow has its reservoir. This reservoir is pressurized by the high pressure bleed air from engine 1. So in case the engine is not able to produce so much bleed pressure, and not able to sufficiently pressurize the reservoir, then there is a valve which opens, which is a cross bleed valve, which will allow high pressure bleed from engine 2 to be supplied into the reservoir. So in normal cases, engine 1 bleed air pressurizes the reservoir tanks, all three hydraulics. Should there be a demand for more pressurization, then the cross bleed valve will open and engine 2 bleed air will be used. Alright, pretty much straightforward. So here you can see on the picture, you have the hydraulics fluid stored in the tank. And this fluid needs to be pumped to operate the green systems, right? So who pumps it? There should be a pump. So this is your engine driven pump. Okay. So on the left hand side, you have the engine 1. The engine 1 has an integral pump which runs when the engine is started, which is called as engine driven pump, driven by the engine, or we'll say EDP. So the green hydraulic system has EDP, or engine driven pump, which will pump the hydraulic fluid from the reservoir to the systems which demands. Now on its way, you can see a valve like thing. What is a valve? It is basically a switch. It can turn off the system, turn on the system. When does it turn off? We'll talk about it later. Basically, this switch that you see is called your the pressure valve, which will turn off and cut off the fluid supply, hydraulic fluid supply to the system when the situation demands. So there's a cut-off switch, and then you have the EDP, and this balloon-like thing is called an accumulator. Now, what is the job of an accumulator? So the green hydraulic system, or all the systems, will have its own corresponding accumulator. The job of it is when the demand, when you operate certain switches, say for example in the green system you operate the landing gear, there is a sudden demand for an hydraulic pressure, right? You need it instantaneously. You don't have time for the pump to pump the fluid, pressurize it and operate. So for that sudden transient demand, the accumulator will help. The accumulator has pressure in it. It will supply that. When the transient demand is there, it will supply the pressure instantaneously until the engine driven pump takes over. So that there is no fluctuations in the pressure. So the accumulator for each corresponding systems, the job is the same. It is to handle transient demands so that there is no fluctuations in pressure. So that forms the green system. The reservoir, the switch, and then you have the EDP, and then the accumulator pressurizes the green system. The tank is pressurized by the high pressure from the engine 1. When the bleed air is sufficient, if it's not sufficient for XYZ reason, then we'll use the engine 2 bleed air by the cross bleed. I hope this is very clear. It's pretty much straightforward. Now the same system can be displayed on your system display page on your aircraft. The second screen, which is at the bottom, will show you the same thing. Here you can see on the bottom, you can see the reservoir. So the amber line that you see at the bottom, or the amber box, is the low level indication. The arrow that you see on the left hand side, hopefully you can see, is the current level of hydraulic fluid. How much do we have? So if you say lose hydraulic or you have a leak, what happens? This arrow will keep coming down, coming down, coming down. The moment it reaches the yellow bar, then it triggers a warning. So in ideal cases, this green arrow that you see on the right should be in the green box on the right side. As long as it is within the green box, it is within normal levels. Then you have the valve that is to cut off the hydraulic fluid. So right now it's in line, which is showing that it is allowing the fluid to flow. This box structure is called the engine driven pump. The pump indication is the box structure. It is also in line right now in green, showing that it is pumping the hydraulic fluid. If it was not, it would be horizontal and will be in amber. This one indicates the engine 1. Engine 1, the engine 1 is supplying the pump. So this engine 1 is in white. If the engine is running, it will be in amber when the engine is not running. So you can see this is the pressure. We'll talk about the pressure limitations later. It is being supplied to the green system. This arrow indicates that the pressure is going forward to the green system. So I hope you guys understood the basic functionality of a green hydraulic system. Now let's talk about the yellow system. Yellow system, there is a little bit to talk about. Okay, so yellow system, the working of the reservoir is same. The reservoir is where the yellow pressure hydraulic fluid is stored. It is pressurized by the engine 1 pump, engine 1 high pressure bleed air. or the cross bleed if the pressure is not sufficient. So the yellow hydraulic comes like this. There is the valve just like in the green system. Right now it's inline, it's allowing it to flow, and then you can see the EDP2, which is the engine driven pump of engine number 2, which is the starboard side engine. So this pump is again run by the engine, which pressurizes the fluid, and then it goes to the yellow system. Again, you have an accumulator for the yellow system to take care of the transient demands of the surge. What is extra that you see compared to the green system in the yellow system is that the yellow system has something that is on the right side here. You see, this is called a electric pump. This is a independent pump that is there to pressurize the yellow system in the case when the engine is switched off. So engine driven pump only works if the engine is running. So if the engine is off and you still want, for some reason, what are these reasons, we'll look into it later, you still want to pressurize the yellow system, then the yellow pump can be turned on by the crew or by the ground staff when they operate cargo doors. Again, we'll talk about it later. The understanding part is there is a pump electrically supplied, not dependent on the engine, which can pressurize the yellow system. The same can be seen here. See, on the picture, if you can look on the right side, you can see that this is saying low pressure. Why? Because the engine 1 is in amber. When it is in amber, that means the engine is shut down. If the engine is shut down, the pump won't work. There is low pressure, which is why low. Engine 2 is shut down, so again low pressure. So that is EDP. But what you can see on the right side here is the elect pump. So this indication in green and the line showing this way indicates that the green pump is running. It will be white in color in normal cases. If it is green in color, that means the yellow electric pump is running, and that is pressurizing the system independent of the engine. So we talked about two ways in which the yellow system can be pressurized. Engine driven pump, just like the green, and then the electric pump. There is a third way. So in normal operations, we look into it in detail. So the ground staff needs to open the cargo door when the aircraft is parked. At that time, engines are off. The electric pump is not on until something happens. So one of the situations is you have to turn it on manually, and the second one is when the cargo, there is a switch at the bottom of the aircraft which will turn the cargo doors. When the cargo doors are turned on, what will happen is this cargo door switch will trigger the yellow pump to turn on. Okay, so the ground crew just flicks a selector valve. It will from close to open the cargo door. The command is sent to the electric pump. The electric pump automatically runs and it will pressurize the yellow system. In this case, it will only pressurize the yellow system. In other cases, it will pressurize the green system, but we'll talk about it later. So only the yellow system gets pressurized when the cargo doors are opening. Cargo doors opening because it's a big door, right? You need pressure to open it. They flick it, it will turn the pump automatically. The pump will pressurize the yellow system, which will pressurize the hydraulic cargo doors below. So what happened if the electric pump, the yellow electric pump is, say, not working that day? Cargo guys come in, he wants to open the door, he flicks the switch, the pump is not working. Now how do you open the door? Because you cannot let a person near the cargo door when the engine is running. So the yellow system had a engine driven pump that is off, the electric pump is not working. So we still need to open the cargo door, right? So for that, Airbus has designed something called as a hand pump. So you must have seen pumping water from underground, right? A pump. The similar principle, there is a hand pump, there is a rod. I'll show you the picture. You will pressurize it by physically pumping it, and that pump will pressurize the yellow hydraulics and can open a cargo door. So what are the three ways in which the yellow system can be pressurized? EDP, electric pump, and then the hand pump. So these are the three systems. Now remember, when you manual hand pump used to pressurize the yellow system to operate the cargo door, there is no electric power. Okay, so in that case, we'll talk about PTO later. Nothing else get pressurized. The yellow system, the entire system doesn't get pressurized. Only the doors will get pressurized, and then the alternate braking and engine 2 reverses. Why is that happening? Let's not talk about it. It's a bit more onto the design side of things, but understand that When you pressurize hydraulics just to open the cargo doors, not all systems get pressurized. We will see examples when we watch normal operations. Alright, so I hope the yellow hydraulic system is clear for you. Now let's talk about the blue system. Now blue system is very interesting. He's not going to do, like, the blue system is not going to do a lot of heavy duty works, but they are there for, they will assist you in certain things, and they're primarily there for emergencies. But in normal conditions, they will always be working, and it will always assist the green and the yellow systems. Now remember, the systems work in together. Sometimes one system will be operated by green, the blue, the other will be operated by the green, the yellow, the other will be operated by green, blue, yellow, all three together. So it's a combination always. Let's see that in a while. So the blue system, let's talk about it, has the the reservoir, again pressurized by the engine, one high pressure bleed. Now this one does not depend on an engine. It has an electric pump for itself. It does not work with an engine. It doesn't have an EDP. It only has an electric pump. This electric pump will supply blue system. It's simple as that. Blue reservoir gets pressurized by HP bleed. High pressurized fluid gets pumped by the electric pump, which will go to the system. So what happens if this pump fails? You still need the blue system to work, right? Because it's still using, the pressure is still used for certain systems. So if your electric pump fails, what we can do is, there is something called as a rat. Now what is a rat? It is kind of like a fan, okay, which gets deployed from underneath the aircraft. Ram air turbine, it's called a rat. You must have seen the pictures. If not, don't worry, we will see it in the coming lesson. So this rat runs when the air is there. That is, when you're flying, right? Airflow spins the rat. The spinning of kinetic energy is used to run a pump, which will pressurize the hydraulic system. Okay, so that is how the blue system is working if the blue system's electric pump fails. Now, how does the rat get deployed? The rat gets deployed under certain emergencies. Whereas when you lose full electric power, this rat gets deployed. In that case, alright, this is part of electrical system. In that case, the electric pump, the rat runs an electric pump, which pressurizes the hydraulic system. This hydraulic pressure is used to run an emergency generator. Okay, that emergency generator will give you some kind of critical systems back online if your engine 1 and engine 2 generators are lost. You lost engine 1, engine 2 generator, APU is not working, full blackout. Yes, your battery will give you some systems, but full blackout. Then the rat automatically deploys, runs the rat, pressurizes a pump, the pump runs the hydraulic system, which will operate an emergency generator and give you some kind of electric power back. So the rat can be used to give you hydraulic power and also some kind of electrical power. That is what I wanted to say. So again, this blue electric pump is automatically started. When it will get started, we will see in the coming videos. Blue automatically gets started actually after the engine 1 started. It will automatically start the electric pump. You don't have to control it. But if you, for example, for XYZ reason on the ground, you want the blue system to be pressurized, on your overhead panel at the back side, you have a maintenance panel. If you have your picture of your Airbus A320 cockpit, look at it, you will see something like this. Okay, there you will see blue pump override button. So on the ground, if you have some electric power, you want to pressurize just the blue system. The blue is off because everything is off, right? In normal case, when engines are shut down, everything is off. No system is pressurized. If you want to individually pressurize yellow electric pump, you have a switch for it. How it works, we'll see it. Similarly, we have a switch for blue system also. The blue pump override push button switch, you turn it on. It will run this pump on the ground with engines off, and then it will pressurize the blue system. So these are the basics. Now here you can see on the ST page, this is your inline. The pump is inline, that means the pump is working. Electrical pump. Why? The blue system does not have any other system. So you can see the hydraulic fluid is stored here, similar indication like any other. So this is your pump, electrical pump, which is supplying the blue hydraulics pressure. You see the rat is available here. Right now it's white, which basically means it's not working right now. If it's working, it will become green and it will supply the hydraulic pressure. So the indications are very simple, very straightforward and easy to understand. So these are the basic three systems that we have: the green, the blue, and the yellow. I hope that part is clear. All right. Now let's talk about the second part of the operations, which will include your application side, the range, and the architecture. Let's go one by one. So what do you mean by application? Application is where these hydraulic, we saw systems, right? So what are these systems? What does the hydraulic, why do we need the hydraulic pressure? What does it operate? So as you can see, it operates pretty much all of the machineries or the things that moves. Okay, your flight control surfaces, which is basically your flaps, your slats, your ailerons, everything are operated on hydraulic. The slats and flaps, your horizontal stabilizer, which is the tail part of it, the reversers for engine 1 and engine 2, your emergency generator, which we talked about, the rat which supplies the generator, then the cargo doors, which we talked about, and then the landing gear, the nose wheel steering, and the brakes. So you can see that hydraulics is very important. It's a big aircraft. It's a lot of control surfaces. It moves. You need some kind of energy for it to move. That is generally the job of the hydraulic system. Next, we will talk about the range of operation. Alright. So you can see in normal cases, your hydraulic pressure, okay, it's always in pressure, PSI, right? So this pressure is 3000 psi, which is the normal operating pressure for a hydraulic system. So if you remember in your SOPs, in your top of line checks, you check each system, right? So you need to know that this is your normal operating pressure. If it is less than 3000 to say 2700, you need to be like, why is it a little bit less? So why is it a little bit too much? So if you want to know that, you need to know what is the normal operating range. The normal operating range is 3000 psi for all the systems, except if the rat is supplying the blue system, then the normal operating PSI is 2500. Rat cannot give 3000 PSI. The rat can only give 2500 PSI, and the rat is only for the blue system. Alright. So 3000 is the normal PSI. When rat is being supplied, it is 2500 PSI. Okay. Now there is something called as a PTU. You can see here. We did not talk about it. We will talk about it in detail. But PTU stands for Power Transfer Unit. Its job is to transfer power from one system to the other system. And it is only between green and yellow. Yellow, green, green, yellow. PTU does not handle blue systems. So when does PTU, what does it do actually? It doesn't transfer any hydraulic fluid. It's not fluid transfer from one to another. It cannot physically transfer fluid, but it can transfer power or pressure. So say the green system, some issue, the pressure is dropping. The yellow is the healthy system. It's an independent system. Right? Ulta, I said, this side is green, this side is yellow, but you get the point. Say one system, say the yellow system pressure dropped, the green is working fine. The PTU will automatically pressurize the yellow using the green system. Not by physically transfer of fluid, its mechanism is different, we don't need to learn about it. But it can pressurize one system using the other system. The ulta can also happen. If the green is less and the yellow is high, the yellow system can pressurize the green system via the PTU. Now when does it, see the thing with PTU is if it keeps running, it becomes overheated. So that is the concern, right? So you don't really want it to operate when there is like say 100 psi difference between, one is 3000, one is 2900. It will only operate when the pressure difference between the system is 500 psi. So if say the green, more than 500 psi, say if the green went to say 2200 psi, yellow is at 3000 psi, then the PTU will transfer that. So right now, if the pressure is 3000, it's in green. If it goes below 1450 psi, it will turn amber. So 3000 psi, normal, 2500 when supplied by the rat, 500 for PTU to work, and 1450 is when it becomes amber. These are all common questions, which is why I reiterated it. Now let's talk about the architecture. So this is something that you will keep coming across, architecture of a system. Architecture of the system just shows you what the basic, it's like a block diagram. It will show you what each system is supplying, and this will help you understand the consequences if a system fails. For example, The green pressure system supplies what all? The right aileron, right spoiler 5, right slat, wingtip brake, yaw damper 1, reverses engine 1, normal brakes, landing gear, slats and flaps. Okay, there is something called as a priority valve. Priority valve is used to say if there is a big demand and the system can't supply all the system, if you make it work multiple switches at once, which is not correct. If you happen to do that, the hydraulics is not sufficient to run all the system at once. There's so many systems, right? So then the priority valve will kick in and it prioritizes landing gear and slats and flaps. That is more important for it. So it will give the pressure to those systems first, and then one system is stabilized, it gives the pressure to the other system. So that is what is priority valve there for. So you see, say suppose your green pressure system fails. How do we use the architecture? The green has failed, although it will show in your status page, okay, the system has failed, these are the inoperative systems. It should also come to your mind if you look at this diagram that, okay, the green system failed, my normal brakes is not going to work. But I have my alternate braking, which is supplied by the yellow system. See, this is system knowledge. Say your green system stopped working, your landing gear cannot be extended. Okay, if there is no green pressure, alright, the PTU will take care of it. If the green fails, the yellow will transfer power to green, so the green gets back online. But if the PTU is also not working, you lost the full green system, then you can't operate your landing gear. Then you have to manually extend it. Again, the system will tell you all these things. So this is the basic idea. So for example, if the yellow fails, what happens? The flaps cannot work, right? But the flap is also operated by the green system. Correct? The green also has flaps. Yellow also has flaps. So the green can still operate the flaps even without the yellow. So you know that the flaps is going to work, but earlier there were two systems that was handling the flaps. Now there is only one system. These are the cases where you will have an indication on your system display page, which will say flaps slats slow or flaps low. Basically means that it will work, but it will be slow to react. Then you have to take that time into consideration when you're preparing or configuring the aircraft for the approach. Alright, so this is the basic fundamentals of understanding architecture. This one image will help you understand what happens if a system fails. You will see this leak measurement valves, which I'm not going to talk much about. On the maintenance panel also there will be leak measurement valves. It's for the AME to operate. We as pilots don't need to operate it. It is just one system that is used to detect if there is a leak in the hydraulic. If you are interested in knowing why, we'll talk about it later. Just send me a message and I'll tell you what. So you have the priority valves, which prioritize these systems if there is a demand surge. Alright. So I hope that is all clear about the architecture. So this is your generic overview of operations. Now let's talk about the next one. Okay, let's talk about the third part in operations. Now third part of operations, we will talk about the components. The PTU, RAT and reservoir. There are other components also, but we need to know a little bit more about these specific components. So we'll spend some time here. So we have already discussed about the PTU. What does PTU mean? It means power transfer unit. So we've seen in basic the working of it, right? It does not transfer hydraulic fluid from one system to the other, but it is capable of transferring hydraulic pressure from one system to the other, and it works only between the green and the yellow, or between yellow to the green. It's either of the other. It's between vice versa. Blue has nothing to do with PTU. That is one thing you need to understand. So this is what a PTU will look like, and it is located. If you ever walk around the aircraft, you will see the landing gear. You will see a compartment inside. There you will see this PTU, and this is when it works, it makes that barking noise that is very famous in Airbus, right? You will see boom, boom, boom sound, which is basically the PTU keep working. All right, and it works under certain cases. We talked about one of them, which is when there is a pressure difference of 500 psi between two systems. So this is the internal diagram. You can see that there is no way in which hydraulic fluid can be transferred. There is no physical movement of fluid between this. But we don't need to learn in depth about the working of the PTU. You only need to know that the pressure can be transferred from green to yellow or yellow to green. When does it work? It works when there is a pressure difference of 500 psi. Okay. Now, remember the yellow electric pump? So if you are on the ground, engines are off, you switched on the yellow pump. Okay, you personally wanted to pressurize the yellow pump. When you switch on the yellow pump, what happens? The yellow electric pump kicks in. It pressurizes the yellow system. When it pressurizes the yellow system, the green is at 0, right? Because the engine 1 is turned off. So now the PTU will detect that 500 psi difference and it will transfer from yellow to the green. So if you turn on yellow electric pump on ground, it will pressurize the yellow system and the green system via the PTU. Okay. But remember the ground crew turning the cargo doors and pressurizing the yellow system. When that happens, the PTU knows it is the ground crew who's operating. The control logic is in such a way that the PTU is inhibited. So when the control knob, the selector valve is open for the cargo doors to open, it will only pressurize the yellow system. But by turning on the yellow pump, right, that their actions also turns on the yellow pump. But if we manually select it in our overhead panel, then the yellow pressurizes, PTU turns on, and it pressurizes the green system. Okay, let's talk a little bit more about the PTU. This might seem a little bit out of place, this video, because I have added it after I have completed the whole lesson, because I wanted to correct certain things and make the information more clear to you. So a little bit more about the PTU. So PTU has some inhibition logic. So right now I said, okay, if the PTU cargo door is open, if the cargo door is opening, the PTU is not going to work, right? So that is one of its inhibition logic. That is, it will not operate for 40 seconds when the yellow electric pump is turned on due to the cargo door opening. Okay, so 40 seconds after the cargo door is opened, it is inhibited. So these are the inhibition conditions that I'm going to talk about in this part of the video, to make you understand the working of PTU better, when it works and when it doesn't work. So the conditions for PTU to work is the difference should be between the green and yellow should be 500 psi. That remains the same. And it is an AND condition. That has to be there and. Okay, both master levers are off. Okay, that is one condition. Or both master levers are on. Or nose wheel steering pin not in towing position with parking brake released. These are the 3 OR conditions. So I'll go one by one, so we'll be more clear about when it is happening. And then PTU is inhibited during the use of cargo door hand pump and for 40 seconds after its use. So whenever cargo door is being operational, 40 seconds after its use, it is inhibited. So that we already talked about. When the cargo doors are opening, only the yellow system gets pressurized, the PTU is not going to work. That we already knew. Now if we are in air, and say one hydraulic lost its pressure, so what is going to happen? PTU runs, the PSI is, say it's 500. If 500 PSI and when you are in air, both your master levers are on, right? So the PTU is going to work. So it's not inhibited. So I'm going to show one by one cases from the bay till pushback till start, and then some examples of single engine taxi to tell you, to make you understand how and when the PTU actually works. So the basic condition is it has to be 500 psi for it to work. The sub conditions we'll look at it one by one. Say you are at a bay. You're going to see this example in one of my videos. Later I'm going to show, but in that case I'm not explaining this particularly. Like I said, I added this video afterwards. Okay, so just notice this. This is the reason why the PTU is not running. Later when you see the video about certain normal operation conditions. Okay, try to relate this to that. So at the bay, your engines are off, so both your master levers are off. You turn on the yellow electric pump. So what is going to happen? Yellow pump is turned on, your yellow gets pressurized. So the 500 psi, yellow gets pressurized to some 3000 psi, right? So when it reaches 500 or above, what is it? It is going to show a difference of 500 between the yellow and the green. So the first condition is ticked. And what? In this case, both your master levers are off, right? At the bay, you have not started both your engines or either of your engines. So both your levers are off. Engine 1 and engine 2, those levers are off. So PTU will work if you turn on the yellow pump at the bay because both your master levers are off. So at the bay, engines off, master levers are off. When yellow electric pump is turned on, 500 psi it will detect, PTU will work. This is the reason why it works. So relate this when you watch the video later on, because I will not be highlighting this part in that video. At bay, engines are off, cargo doors open. So this also I'll show you in the next video. We'll be at the bay, both engines are off, but the cargo doors are opening. So cargo doors opening is via the yellow electric pump, like I said. But what happens this time is that the yellow pump will pressurize only the yellow system because the PTU is inhibited for 40 seconds. So that is the second case. So PTU will not be working based on this condition, even though both masters are off. Now next is aircraft pushback. So now next is there, say you're pushing back. So when you're pushing back, you will connect the nose wheel steering pin. Your parking brakes will be released. Parking brake released, nose wheel steering pin will be on. So what is nose wheel steering pin? That is a pin that is connected for the tow truck to disconnect from your hand steering. So tow truck will be controlling your nose wheel steering. So if you don't know it, just Google about it. It is pretty much straightforward. So there is a pin that you put in the nose wheel. For the ground crew will put it in. And then you will push back. The tow truck is pushing you back. When you push back, is as per your SOP, you will start one engine. So in the case of a normal 2-engine startup, that is, you're not going to do a single engine taxi, then in that case Airbus asks you to start engine number 2 first, followed by engine number 1. If you're doing a single engine taxi, or in Indigo generally, we generally start the engine 1 first, and then the engine number 2. That is the order in which we start. The reason for that is, if you have engine 1, green get pressurized, and you can taxi with engine 1, and yellow will be supplied by the electric pump, so that the pressure difference is not there. Green doesn't have a yellow electric pump, so we don't have an option like that, which is why we start engine number 1 in the case of Indigo. If you don't get this part, just don't worry about it, it's not important at all. So let's say you're pushing back, then you started one engine, 1 or 2, whatever it is. Started one engine, immediately you will see the pressure increasing in one of the EDP will start immediately running, the pressure will become 3000 psi. So here also the 500 psi condition is satisfied. Both masters are off? No. You have put one master 2 on, right? So this is not going to work. Both masters are on? No. Only one master is on. Now the third condition is nose wheel steering is not in towing position with parking brake released. Here parking brake is released, but nose wheel steering is in towing position. So when you start only one engine during pushback, your PTU will not work. Why? Because there is a nose wheel steering pin inside it, because you're being pushed back, right? In my video that you will see later on, if I have not corrected it, you might see in the sim the PTU working. Might see. Just make sure if it's there or not. If that is the case, then understand that there is a sim error. Ideally, in the case when you're pushing back and starting only one engine, your PTU is inhibited. Why? Nose wheel steering is in the towing position. Parking brakes are released, but nose wheel steering is in towing position. So PTU is inhibited when your first engine is starting on pushback. Now pushback is completed. What happens then? They will ask you to set the parking brake. We will set the parking brake. And when the parking brake is set, he will remove the nose wheel steering pin and he will walk off. And then we start the second engine. That is the procedure SOP if you don't know. So pushback is complete. Parking brake are now set. He will take the pin and he will walk off. So now also one engine has started. I have not started the other engine. So there is a 500 psi pressure difference. Yes. Both masters are off. No. Only one master is off. I have not started the second engine. Both masters are on. No. I have only started the first engine. Nose wheel steering is in towing position. No, it's not in towing position. Okay, with parking brake released. No, this is where it makes a difference now. The parking brakes are set. I have set the parking brakes because the pushback is completed. I have not got taxi clearance, so parking brake are now set. So PTU will be inhibited. Now say I started the second engine. Okay, he is gone, pin is gone, parking brakes are set. I started the second engine. At this time, once your second engine is starting, you will notice the PTU working. This is a self-test that the PTU does to ensure that the PTU works. Because in a moment the EDP2 will kick in and the pressure difference will be gone. If pressure difference is gone, this condition is not met. Anyway, none of the other things, it doesn't matter. It's AND, right? So in that case though, this won't make any sense anymore. So before the second engine fully kicks in, the PTU does a self-test to when you put the masters 2 on, it will do a self-test to ensure it is working. It's a self-test that is done. So during engine 2 start, you will see it before the EDP takes over fully, and then the pressure difference is gone. Then you will never see the PTU running unless you see a pressure difference again. This is the case of a 2-engine start. See, after engine 2 starting, you will during engine 2 starting, you will see a PTU self-test. So that way, yellow pump turned on, PTU works. Why? Because if 500 is there, difference is there, and both master levers are off. At bay, engines are off, cargo door opened. No, it will not work because of this condition. After during aircraft pushing back, engine is starting. Yes, one engine has started, but 500 is there, but this is not there, this is not there, and nose wheel steering is in towing position. So PTU is again inhibited. After engine to start, parking brake is on. So nose wheel steering though is gone, parking brake is set. So that is why the PTU is inhibited. Now during engine to start, you will have a PTU self-test. That is when the PTU works. Now suppose I only started one engine, I am doing a single engine taxi out. So and I am taxiing out as per the single engine procedure, which is a different procedure, you don't have to worry. We will turn on the yellow electric pump. The moment the yellow electric, before taxi, okay, before taxi, we'll turn on the yellow electric pump. So before taxi, if I turn on the yellow electric pump, the PSI 500 will be gone, right? Because the green is there, the yellow is there, both doesn't have a pressure difference, so that is also not gonna work, correct? So that is the reason why it will not work during single engine taxi. Now to start engine 2 during single engine taxi, during taxiing only we'll start the 2. That time we'll turn off the yellow electric pump. At this time will the PTU work. At taxi, during single engine taxi, what happens? 500 PSI will show because only one engine is working. I turned off the yellow electric pump to start engine 2 as per the single engine taxi procedure, which you will learn later. So what is happening? So 500 PSI pressure difference is there. Are both masters levers off? No, only one is off. Are both on? No, only one is on. Is your nose wheel steering in towing position now? No, you're taxiing now, right? So nose wheel steering was long gone back. They removed it long back when they were disconnecting and walking away. So this is not there, and parking brakes are released. Yes, you're taxiing, so we'll brake release and then only you will taxi, right? So this condition is satisfied, and this is also satisfied. So at this time, single engine taxi, the moment you turn off the yellow electric pump, the PTU will start running again. Okay, so this has to be green. Forget this is in red, but don't worry about that. The point is PTU works at this case also. Alright, I hope this is not too confusing for you. Now let's talk about the rat. So this is your rat. I don't know if you have seen it. This is that windmill kind of thing that extends out of the aircraft, the conditions of which we have already discussed. This yellow, the rat pressurizes, the rat operates a pump which pressurizes the blue system. So you can see here the rat is working. See, it was in white in normal cases, right? But it's green now because it is pressurizing it. It goes only to 2500 psi, and then it's showing 2750. It's just incorrect. It's correct. It's 2500 in normal cases. Then you can see this is an electrical diagram. So you lost your AC bus and AC bus 2. If you don't understand it now, forget it, don't worry about it. But you can see an essential bus is run by an emergency generator. So that supplies AC, essential supplies, and through a converter, DC essential also. Understood? The generator always gives AC power. So you need some way to convert AC to DC. So that is the essential TR. So you will see emergency generator, which is run by the rat. So this is something for electrical system, but I just explained it here. So the rat coupled to a hydraulic pump pressurizes the blue system. We talked about it. Rat is automatically deployed, right? It can automatically now when you lose power, or you can manually select it. How do we manually select it? This is your overhead panel. You will see a red switch which is closed and guarded. A red switch closed and guarded indicate that it's a irreversible action. You should confirm with the other cockpit crew before operating those switches. The computer will tell you when you need to operate those switches. Confirm, rat, open, and then press the button. It will deploy the rat. Once it's deployed, you cannot retract it. It will stay deployed. And the rat works on wind energy, right? So you need to be in motion. So the rat minimum speed requirement is 140 knots. This is a limitation that you need to know. Below which the rat is not sufficient enough to pressurize the blue or supply for the emergency generator. The rat stalled close to 100 knots. Just for your information. So it's like the minimum rat speed is 140 knots. The emergency generator only gives you 5 kilowatt ampere. That is that this generator, the rat supply is not capable of supplying all the system, but it will give you back to your critical systems. Alright, so that is your rat. Now what about the reservoir? So as you can see, this is your engine 1. There is intermediate pressure and there is high pressure. This high pressure is used by filters. It's used to pressurize the reservoir tank. All three reservoirs are pressurized by the high pressure of engine 1 as the picture demands, as you can see on the picture. But if there is not enough sufficient pressure from engine 1, then a cross split valve open, which will take high pressure from engine 2 and supply to the tanks. So engine 1 in normal cases, if supply is less, then cross bleed will give you from engine 2. Now why do we need to pressurize tanks? That is the next question. What is so important? This is to prevent cavitation. And if you don't know what cavitation is, if you can see in this picture, if I try to zoom in a little bit, you see these small holes and damages on this inside of a motor. This is because of low pressure. Because this low pressure can create gas or air bubbles, which will collide with the metal and cause significant damage to your motors, which is called as cavitation. Something you can Google about if you want to know more about it. So this is why we need to pressurize the tanks and keep. So pump cavitation is primarily caused by excessive low pressure at the pump inlet, which causes, so at the inlet of the pump, if the pressure is low, that is why we give high pressure at the inlet by pressurizing the tanks. It causes the liquid to vaporize and form bubbles, and these bubbles travel into high pressure zones within the pump. They violently collapse and damage the impeller and housing zones. So a lot of damage. Basically, to avoid that, we have to keep the reservoir under pressure. So if you remember the reservoir indication, you must have seen it on the ST page. So this is the low level warning and this is your normal. So this arrow needs to be in this green box. As long as it's in the green box, you're good to go. Alright, if you want, you can look into the values of how much liters or fuel it is, but it's not important for you to memorize. Alright, so these are the components that we looked into. Now let's talk about the indications. Alright, so there are controls and indications. So one thing we're going to talk about first is your overhead panel. So in your overhead panel, this is your hydraulic system. You see hydraulic, and these are your control switches that is available for you in the cockpit on your overhead panel. There is also some hydraulic switches which is there in the maintenance panel, which is at the back right side. Alright, so these are the only switches that is available for you as a pilot to operate. So here you can see the engine 1 pump. So you have an option to turn it off. Okay, now remember, it's not like where you press a button, it is going to turn off or turn on. No. Airbus philosophy is dark cockpit. If something is operational, the lights will be off. Okay, so what do you think? The engine driven pump on the green side has to remain on automatically, right? So here you can see the lights are off, indicating that engine 1 pump is working. If there is some fault, a fault light will come up in amber saying that something is wrong with your pump. Now what if you press it? What do you think indication will come here? If you press this switch right now when it's normally working, it will turn off your EDP1, but indication of off in white will come. Are you understanding? You press it, off will come. So you see, only off is written here. So if you press that, off light will come. So which basically means in normal condition, lights off, it's working. You press it, you can only turn it off. Press it again, you can turn it on. RAT, what does it do? It is an emergency switch. Confirm, open, press, it deploys the RAT. Electric pump is closed and guarded. Why is it closed and guarded in black? Again, this also needs to be confirmed before operating, but it's in black. The guard switch is guarded part is black because it's a reversible action. Alright. So what happens? Your blue electric pump is automatically started. Okay. Now, if you press this button and open up the guard and you press this button, what happens is that it turns off. It's something that is automatically running. So lights off means it's working fine, right? Now if you press it, it will turn it off. So that is the next one, that is the electric pump. PTU, again, it's automatically running in normal cases. If you press it, it will become off. If PTU overheats or if it's not working, some issues, it will come fault light here. Now there is engine 2 pump, which is again working in normal conditions, fault light if there is something wrong like low pressure, overheat, whatever. If you press it, off will come. That is, you are turning it off by pressing it. It's something that is automatically working. Now electric pump, the yellow electric, see this is the yellow system. Engine 2 and elect pump, blue system only elect pump, green system only engine 1. So the yellow system has an electric pump, right? Is it working in normal cases? No, it is off in normal cases. Now if you press it, it will turn on. So on indication will come. Now the green lines are not drawn randomly. It signifies the flow of operation. See, the rat is used to supply blue, the yellow is supplying blue, green is engine 1 is supplying green, engine 2 is supplying yellow, elect pump is supplying yellow, and it is connected. See, yellow to green is selected, but nothing on the blue. That's why there is a loop here via the PTU. Now what do you see on the maintenance panel? You will see a lot of switches on the maintenance panel. You don't really operate this, and it's generally for the AMEs. So the hydraulic part is what we'll discuss here. See the blue override pump. So on the ground when engines are off, you want to pressurize blue system. You lift the switch, you turn it on, it will come on in blue. What does it mean, blue? Go to my daily quiz in Crimson Sky. You will find out what blue light, white light, yellow light, green light, all those light means. So open it up and press it, and then it will pressurize the blue system. So I hope the overhead panel is clear for you. Now let's talk about the system display page, which we already discussed, but we'll just quickly recap. So this is your reservoir. The valve is for green and yellow. It will turn cross if you operate certain switches, which will prevent the hydraulic fluid. Go ahead. Which will stop the flow of hydraulic fluid. You have engine 1, which is operating the engine driven pump, which is this box. This is your engine 2 driven pump. You have 3000 psi for the green system, which is normal. The rat is off. The PTU is not working now. See, if it is working, it will be solid in color. The rat is not working now. If it is working, it will be green and it will become green. Elect pump, this is the blue electric pump. The yellow electric pump is off, which is why it's hollow. If it is working, it will be green and solid. This is your engine 2 driven pump for the yellow system. Alright, so PTU is not working now. If PTU is working, on your memo it will be written hydraulic PTU. This memo appears in green when the power transfer unit is turning. We'll see examples of it. You will see another memo in your EWD page, which is the upper display. Rat out if your rat is working or if the rat has been deployed. Okay, so I hope the system display page is also clear for you. So this in total is the basic operations of your hydraulic system. So we have completed the basic operations, and now I hope you're all clear with how a green system works, the yellow system works, and the blue system works, the components and the indications, and what all control switches we have. Now let's talk about some examples. This is just to understand the practical application side of things and how when do we actually operate certain systems, and generally a normal line examples, examples of when we have to operate certain switches in the hydraulic system. This is to help us understand and see how it's working. Alright, so if your basic systems is thoroughly understood, your normal systems will be also easily understood. So let's talk about the first example that we're going to talk about. Cargo door operations. So do you remember the cargo door operations that we talked about in the basic operations that when we talked about it? I hope so. So the aircraft is in transit. The video that I'm going to show, the aircraft is in transit, which basically means that in all these examples for that matter, do not worry about the SOP part. Just focus on how the system works. Okay. So aircraft is in transit. You have set up some of the things. Your aircraft is powered is what I'm meaning. It's not a cold and dark cockpit. So first we are going to open both the cargo doors. We will see how the cargo doors open. Basically it's done by the ground staff. We as pilots don't open the cargo doors. We don't have any controls inside the aircraft. But of course in the video I'm going to use an iPad to open the cargo doors because it's a simulator game, right? But in actual case it is done by the ground staff. The APU is available, which indicates that okay, you have AC power available for you. So what are you supposed to know? So you as a crew, you're supposed to notice in this video the ST page while the cargo doors are operated. Okay, you need to see what is happening on the ST page when the ground staff opens the cargo door. When I physically turn on, you as a pilot, okay, for example, if you are inside the cockpit and you turn on the yellow electric pump, what happens? So the difference between them operating a yellow pump and me operating it using a overhead panel. The memo when the PTU starts operation, and then there is also something called as a bulk cargo. So forward 2, and then there is one at the back that's called bulk cargo, which is a small cargo door, which we don't really always use. So what happens when we open that? What hydraulic system gets pressurized? So this is what we are going to watch. So let's start watching. So you can see here all doors are closed. Okay, so this is an iPad that I use in the sim to open the cargo doors. So you can see here, see earlier it was all green. Now this is your cargo. These indications are all doors, avionic doors, your left cabin door, right cabin door. This is another avionic door. You have a cargo door, your slide doors, and then your aft cargo, bulk cargo. So I turned on the forward cargo, opened it. So amber means open. Cargo, the aft cargo and the bulk cargo. So you can notice, see the cargo doors opening. So this is your bulk cargo. This is your aft cargo, and this is your forward cargo. So these doors are opening, right? So this is done by the ground crew, not us. Okay. So when that happened, what is happening to your ST page? Did you see? When that cargo door was opening, it's a big door, right? So you need hydraulic pressure to operate that door. So when the ground staff opened the door, the electric pump automatically turned on, which is pressurizing only the yellow system. If you remember from the architecture, it is the yellow system that operates the cargo door. In this case, the PTU does not work. It is inhibited. Okay, the PTU knows it is the ground staff is operating for the cargo door. So the electric pump will run, which is that sound you might hear after parking if you are traveling as a passenger. Once the aircraft is stopped, you will hear a beep sound, right? That is the electric pump running. It is pressurizing the yellow system. Clear? Makes sense? So yellow pump automatically stops when the cargo door is fully open and the yellow depressurizes. Because if there is no pump, there is nothing else to pressurize the system, right? Now this is your overhead panel. We talked about it, right? All the same switches that you can see. Now I'm going to operate the yellow pump. Remember, when you press it, it becomes on, right? Because it's normally off. So when I turn on a yellow electric pump, what happens? See, this time the yellow electric pump runs. When it runs to a certain PSI. Then this time the PT will start running, because the PT knows it is you who turned on the pump. When you turn on the pump, when it pressurizes, it detects 500 PSI difference. The PT is running. See, it's transferring yellow to green, and then the yellow gets pressurized. The green also get pressurized. Important point: when you turn on the pump, yellow get pressurized. PTU detects the difference. PTU runs, and the PTU pressurizes the green also. And you can see on the top, hydraulic PTU. That is the PTU is running. You will hear that barking sound when the PTU is running. Clear? So this is what happens when you turn on the electric pump. When you turn it off, see, it depressurizes. Both hydraulic pressure is on. Got it? Now let's operate the cargo doors again, this time to close it. Now the cargo doors are closing. See, the front cargo door is closing, right? The bulk is also closed. You can see. Let's try one more. Let's try closing the when it closes, the same thing happens. The yellow electric pumps just pressurize the yellow system. I was not pointing to ST page then. And the same thing happens when you close it, just like how it was when it opened it. But notice now, when I turned the bulk cargo, there is no pressurization happening. This is because the bulk cargo door, which is the small cargo door here at the very end of the aircraft, is a very small door. You don't need hydraulic pressure to operate it. It just turns on its own. It just can physically move. So bulk is not operated by hydraulic pressure. Clear? I don't know why this comes, but anyway. Alright, so we noticed the ST page where cargo doors are operating. You know what? I hope all these things, the use of yellow electric pump, memo when PTO comes, and use of bulk cargo. Bulk is not operated by cargo is basically my point to convey here. So I hope this makes sense. Now remember I told you if your electric pump is not working and they operate the switch to, this is that switch. See the manual selection cargo door. It has open and close. You put on open, yellow electric pump on, yellow system pressurized, cargo door open. Put close, yellow pump on, yellow system pressurized, cargo door closes. So that is the switch. Remember, in case the yellow electric pump is not working, there is an option to pressurize the hydraulics to open the cargo door, which is the hand pump. So this is your hand pump. You see under the aircraft there is a rod-like thing which is also kept inside it. You will take it, you will fix it, and you will pump it. This person keeps pumping, he is holding it in open position, and then you pump it to pressurize, and the cargo door opens. This is how you can pressurize the yellow pump the third way. Okay. Hope this is clear for you. Okay, so let's see the next one. This video again was updated later on, so some things might be out of place, but rest assured you will understand everything if you just follow what I'm saying. So in this part, we'll be discussing how do we energize a blue hydraulic system on the ground. So if AC power is there, there is a blue pump override push button which we saw. So if you just press it, it will get pressurized, of course after getting clearance from the ground crew. Then second thing we'll discuss is when does the blue pump start in a normal case. So that is all hydraulic systems are automated, right? So yellow gets started with EDP1 when engine 1 is starting, green gets pressurized when engine 2 is starting, if PTO is not working, and then when does blue start? So that we will discuss and see in our video next. Then I'll show you how does the PTO inhibition logic that we discussed about in the basic system operations of PTO, we will see it in real, in different cases, different stages. When does PTO work, when does it not work, and why is it not working? So that inhibition logic, if you're not familiar, we will see it in the video today. And then single engine taxi example also I'll show you. So single engine taxi, remember if you don't know what it is when you taxi out with a single engine to save fuel. And then while taxiing, we'll start the second engine. So aircraft is capable of taxiing with one engine in most of the cases. That again depends on the conditions, but most cases we can do that. So we will discuss that also. We'll see a small example of that. Now remember one thing, as per ACCUM procedures of Airbus, you are supposed to start engine number 2 first and then engine number 1. Now if you look at the latest ACCUM procedures, if you're doing a single engine taxi, you will notice that we'll be starting 1 and then the engine number 2, 1 followed by 2, which is opposite to the 2 engine start procedure. But in my videos, I'll be starting engine number 1 in both cases. That is as per my company SOP. So please understand that difference and follow whatever your company is saying. Alright, so AC power needs to be there for blue pump to be energized. So aircraft in transit, APU is available. We'll follow engine 1 start by 2. We'll do a single engine taxi, we'll do dual engine start. So let's start both engines first and see how it goes. Okay. Alright. If this video plays, yes. So you can see the blue pump, this is the hydraulic space, none of the systems are energized, aircraft parking brake is set, aircraft is on the ground. Pretty much straightforward. So you know that this is the blue pump override push button, right? Once you get the ground clearance, we can energize it. And it's as simple as that. You will see the blue pump working and it is pressurizing the blue system. It's pretty straightforward. So you can do this. This will be required under certain MEL conditions which require to test some test systems, or in normal days, line flying, we rarely use it. Yellow pump though we use it for brake accumulator, blue though we don't use it much. Now let's see another condition. So PTO inhibition logic, if you remember from what I had explained before. So on the ground, okay, if both masters are off and the pressure difference is 500 psi, so it's and condition, right? It needs to be 500 psi and both masters are off. This is which condition? That is this condition on the ground, right? If I energize the yellow pump, what should happen? Please revise the PTO inhibition logic. See, the PTO will start running. So this is the reason why PTO is running here, 500 psi. plus both masters are in off position, correct? So PTU will run. So we saw one more condition. So that was one of the PTU logic conditions that we saw about. Okay, don't worry about the SOPs, what I'm doing, just monitor the SD page for hydraulics. That's all that is important here. So hydraulics page, now let's do an engine start. Okay, everything is off, tug is connected, so you can see the nose steering disconnect memo, right? What basically means is that the tow truck, when it's connected, it disconnects us from the handle because they are turning the nose wheel when they are pushing back, right? So our connection is disconnected. So when the pin is there that disconnects our control, this memo will be there. So even if you saw the PTU inhibition logic, this particular case will be there where the pin not in towing position. So here now pin is in towing position and the parking brakes are also set. So will the PTU work? So PTU now for pushback, when you're pushing back, you usually start the first engine when you're pushing back. That is the standard procedure. If you will do ideally you can do it on the bay. You can start engines under certain technical conditions, but in most cases we will be pushing back and starting the engine. And so in this case, I have released the brakes, parking brakes released, ready to push. Then we'll push east or west. Right now I'm just pushing back. So brakes are released, I'm pushing back, and this is when you will start your engine number 1. So mode selected to ignition, starting engine 1. Now engine 1 is getting pressurized. See what happens? The EDP immediately kicks in and the green pump is pressurized. Why is the PTU not running right now? So yes, 500 psi is there. Parking brakes, so both masters are off? No. Here one master is on, so that condition is gone. Both masters are on? No. One master is off, so that second condition is on. Third condition says the parking brakes is released and the nose wheel steering not in towing position. Here the nose wheel steering is in towing position. So 500 psi, even though is there between green and yellow, because the nose wheel steering is there, the PTU is inhibited. Which is why engine 1 started, EDP kicked in, 3000 psi, 500 psi pressure difference is there, but the PTU is not working. PTU is inhibited now. Okay. So let's continue doing that. Say I stopped the push. Pushback is complete. Assume. What do you do after pushback is completed? We set the parking brake. Brake set. Now, once the parking brake is set, we will ask him to disconnect and go. He can go. We can start second engine without him being there. Again, this is airline, depends on airline SOPs. For us, once the first engine is started, or once the pushback is completed and first engine is starting, he can leave. So the nose wheel steering memo, if you check now, is not displayed anymore because he has disconnected it. Now we have controls back and he has gone. And so again, so PTU logic was what? Third condition, because anyway one master is on, so it's asymmetrical. That first and second condition is not applicable. 500 psi is there. Nose wheel is removed, but we have set the brakes before he went, right? Because once the tow truck completes pushback, you have to set the brakes. So since brakes are set, the third condition will not be satisfied, because for the third condition the brakes had to be released. So PTU is still inhibited. Okay. See? So parking brakes are set. That's why the PTU is not running. Only the green is running. Now next, what we'll do? We'll start engine number 2. Like I said, it's a 2 engine startup that I'm showing initially. So when I start engine number 2, even though the brakes were set, ideally PTU is inhibited, right? But PTU runs now because this is the only chance for the PTU to do a self-test. Because the moment the second engine starts, it gets pressurized, right? Now there is no longer a 500 psi pressure difference between green and yellow. So when does PTU the computer needs to check if the PTU is functioning, right? It's a very important component. So second engine start, PTU will, once the master is going to on, the PTU will do a self-test to ensure that the PTU is running. That is why the PTU is working now. This is the self-test. This is even though 500 psi is not there, PTU will work when the second engine goes on, just to do a self-test. Hope that is clear. Alright, so right now all pressure systems are pressurized. Now one thing I forgot to show is when does the blue system gets pressurized. Let's just rewind it a bit. So here you see the blue pump. See, The engine 1 is almost fully started, it's fully available. Right after that, the blue pump automatically starts. So this is what I wanted to show you. The blue pump automatically starts after the first engine is started. Alright, that is the control logic. Once first engine started, blue pump automatically fully energized. This now, once two engines are started, we will release the brakes and we will continue taxiing. No more PTO working after the self-test because both are pressurized. Now let's see the single engine taxi. How does it happen? So again, brakes are released. We are pushing back. So first initial part of first engine startup remains the same. There is nothing difference. You already saw when the PTO is inhibited. So I'll just skip forward a bit so that we save a little bit of time. So single engine taxi procedure says that, okay, your first engine is started. So these are all single engine procedures. You can disregard all these things. So now what happened? Say now the nose wheel steering is not connected. He has left. Pushback is completed, so the parking brakes are set. One engine has started. Blue automatically starts after the first engine is started. Now, if I release the brakes, what will happen? The PTO will keep running because for taxiing with a single engine, we have to release brake and we'll taxi, right? So now if I taxi, the control inhibition of PTO will no longer work. Brakes released and nose wheel steering not in nose wheel steering not in towing position, right? They have disconnected it. So 500 psi is there and the third condition is satisfied. The PTO will keep running the moment I release the parking brakes to taxi. If that happens, see, let's see. I release the brakes. Now I'm taxiing out. See, the PTO immediately starts running. Why? Because of the third condition. Now, if this is happening, imagine the amount of noise that will be there at the back. It will be very annoying for them. So it will be annoying for the passengers, and also the PTO will keep running and that will overheat the PTO also. To avoid that, what can we do? We'll turn the yellow electric pump as part of your single engine procedure. So now what happened? The yellow pump is pressurizing the electric pump is pressurizing the yellow system. So since pump is pressurizing, PTO will stop because the 500 psi will no longer be there because the pump has taken over. So this will prevent the PTO from running while taxiing. That is why in single engine taxi we keep the yellow electric pump on. Now let's say I am taxiing, disregard where I am going, there is a car there, that's all not going to happen in real life. So you taxi out. So is the PTO working now? No. Now the moment to start the second engine, we turn off the electric pump. We need the bleed. So now the PTO starts running as per the third logic. Now we'll have the second engine started. Now second engine will start. The PTO self-test will run for a while because see the pump has kicked in, but the PTO will run. That is the self-test, and after that the pump will stop. Second engine is starting. It will start, and then we will continue with our normal SOP. So these are the inhibitions. Are you understanding? Now in flight, if you lose one hydraulics, PTO will kick in because both masters are on. That is the first condition. So I believe all the three conditions are covered in this video. Now let's talk about the third one. Okay, so this is a scenario which most likely you will face during your training or in line flights because you might forget the flows. It's not a sin. Okay, so in this case, you came in, you landed, you were rolling, you vacated, ATC gave you some taxi instructions, you wrote it down. After landing flows, if you remember from your SOPs, you start with your weather radar and predictive ensure, turned it off. You the PIC disarmed the spoilers. You come, you forgot the flaps, you did the TCAS to standby and everything. You did everything except the flaps. The flaps were at full. Remained at full. You went in, parked the aircraft, shut down the engines. It's not a sin. You can forget SOPs. It's not a sin. Now what do you do? So you are panicking. Okay, this is my first SLF. I don't want the trainer to find out that I missed. I put flaps to 0. This is what happens. Is this the right action? No, absolutely not. Not professional from your side, but you did it. We'll see the consequences of doing something like that. And second, what is the right way to do it in case this kind of situation happens. So first we'll try putting flaps to 0. We'll see if something happens. There is no hydraulic pressure. Ideally, nothing should happen. Then we'll put flaps to 0 when the cargo door is opening. What happens? And third, we'll see a situation. What is the appropriate method to do this? Okay. Again, do not pressurize any system until you get the clearance from ground. All right. Let's watch. So your flaps are at full, your engines are shut down, you came in and you landed. Okay, see, engines are off. Flaps are at full. You can see S and F. This is your slats, these are your flaps. It's both at full. Now what do? You're in a pickle. Not really, it's nothing basically. Your mode selector should be normal, okay? I forgot this, but disregard the SOP part. So I put flaps to 0 now. Will anything happen? Will the flaps and slats get retracted? No, it won't. There is no hydraulic pressure. Who is applying hydraulic pressure? Blue pump is off, yellow pump is off, EDPs both are off. There is no pressure only. So, will the flaps go in? No. So, this will not work. So, you tried it, it didn't work. So, let's return it. Let's put it back to full and let's see the second situation. Okay. This time, you park the aircraft, flaps are at full. Okay. And then, you told the ground staff, see, I put the flap, I want to pressurize the yellow system. You got the clearance. Put the yellow pump on. Let's see, the yellow pump will pressurize the yellow system. The PTO will pressurize the green system. Now you put flaps to 0. So what did you do? First you tell PIC, so, Captain, I forgot my flaps at full. I forgot to retract it. He said, no worries. No one will bother. He said, no worries. Tell the ground crew that you're pressurizing the yellow pump. Call them. Tell them cockpit ground cockpit, confirm clear to pressurize the yellow system. We need to retract the flaps and slats. He will say, area clears, Captain. You're clear to pressurize the yellow system. Turn on the yellow pump. Yellow pump will retract both slats and flaps. What do you notice here? You see how slow it is retracted? Because these yellow pump output flow is much lesser. I forgot the value, but it's much lesser than the engine driven pump. Engine driven pumps are more powerful, so it can pressurize quickly. This yellow pump, it works, but it will take its time, which is why it is slow for retracting flaps and slats. You can see how many seconds it takes. It takes quite a while. It's quite slow, but it will do its job, no doubt about it, because both yellow and green is working, right? Alright, so that worked. Problem sorted. Not an issue at all. So if you make such a mistake in your line or in your sim, do the appropriate action. Let him know, let the ground staff know, and do the right thing. Now let's return back to the situation again. Say I put the flaps full. Again, we are resetting it. The flaps were at full. Let the slats also come in so that it's similar to the situation we had before. One more condition. So this time you didn't want to tell him. You put the flaps to 0. You notice nothing is happening. And at this time the ground crew opened the cargo doors to offload the luggage. Let's see what happens there. The pump is off, everything just like how it was initially. Okay, let's depressurize fully. So this was the situation, right? You came in, you parked, engines are off. Now let's turn on the cargo door. See, when the cargo doors are operating, remember the electric pump pressurizes only the yellow system now. PTO is inhibited at that time. Now you try to put the flaps to 0. What happens? Say some guy is standing holding the flap. You don't know, right? These guys, they're not trained like us. So if that happens, what happens? See, the flap starts retracting, right? If his hands are in between, it will get crushed. You will be responsible. Now tell me one thing. Why is that the flaps are retracting but the slats are not retracting? Earlier when yellow pump got turned on, it retracted both. Here also yellow pump is turned on, but only the flaps are get retracted. Remember, when it is operated by the cargo door, only yellow system gets pressurized. Hydraulic PTO is inhibited, right? So in this case, since only yellow is getting pressurized, if you remember your architecture from your basics, Sorry. Alright, see, if only your yellow is there, your flaps can work. Alright, you need your green for slats to work, or you need your blue for your slats to work. Is your blue there? No. Is your green there? No. Why? Because PTU is not running. So with yellow alone, only flaps can work, which is why the slats did not retract. Is this clear? Now the yellow pump turns off automatically when the cargo door is fully open, and it is still at 1. See, and it is very instant. You don't even have enough time for it to fully retract also, because when the cargo door is open, the electric pump turns off on its own. So this is not right. This is incorrect. Dangerous. Something happens, you are at risk. Pressurize the yellow pump correctly after telling him. This time, yellow pump will run. PTU will transfer power. It should run. I didn't do the full thing, but transfer the power. Green will work, since based on the architecture, green can retract slats. Or else you'll have to turn the blue. That's not required. Why you want to turn the blue? Use the yellow electric pump. It's a PTU to transfer yellow. Alright. So first 2 is done. Let's look at the third one. Sorry, 1, 2, 3 is done. Let's look at the fourth example. This is one of the reasons one of the most common time where you will actually pressurize a yellow system. So from the architecture also you can see that it is the yellow system that handles the parking brake. Okay, normal parking brakes are operated by the yellow system. The parking brakes are operated by the yellow system. So it's basically the accumulator which supplies the pressure when the engines and everything is off, because pumps are not running, right? So who gives that pressure? You remember the accumulator who handles the transient pressure demands? He is capable of supplying pressure to the brakes. So the brakes gets engaged, and that pressure of the accumulator will hold the aircraft stationary. So like you see, the accumulator is what is supplying the brakes pressure. Now where is this indication there? There is something called as a triple indicator. If you remember, you will see 2 needles at the bottom, which is one is for the right brake, one is for the left brake. If the brakes are pressurized, both needles will go up, showing how much PSI. The more, the stronger the brake. More PSI, so it will show something like this, which showing that the left and right brakes are engaged, because both brakes are independent of each other. It's not like one you press both. You have right toe and left toe. Both are separate, just like how it is for your Cessnas. So you can see the brake pressure indicator, which is the bottom one, which will show you how much pressure is applied to the brakes. And then you will see a needle on the top, which is your accumulator pressure. Remember, accumulator is able to have some sort of pressure. It can store the pressure, but it is not going to be there forever. Like if you don't have any other system that is pressurizing the accumulator, over a period of time, the accumulator will lose its pressure. It's like a balloon, it will deflate eventually. Not deflate, I hope you understand what I'm trying to say. So in this video, what we're going to do is we're going to turn on the parking brakes. Pressure will rise up. Accumulator is holding the pressure. This pressure accumulator will hold for 12 hours. It's written in your books. You can find it in your ACCUM. 12 hours, it's supplying the parking brakes. After a period of time, it will start losing the pressure. So now if you want to pressurize the accumulator again to use the parking brake, you need to drive certain pumps. So since it's yellow system, you either have to turn on the engine or use the yellow electric pump to pressurize the accumulator, which can then get its pressure back and hold the parking brakes. So in this example, I'm going to use the parking brake knob on off a lot of time, so that it does this a lot of time, and the accumulator eventually loses its pressure. And we'll see what happens, and we'll see how we can repressurize the accumulator. This is what we'll be looking at in this case. Aircraft is parked at bay. Transit crew notices brake pressure low during cockpit preparation. So if you remember your cockpit preparation, you will do a U flow, right, where you will check the brake accumulator pressure. We'll also do it before walk around, things like that. So when you check the pedestal, and also when you do your before walk around flows, you will check accumulator pressure. You checked it, you saw it is less. What does it mean? That means there is not going to be sufficient pressure on your brakes. It's risky. Aircraft might roll if there are shocks in place. So we will talk about how to pressurize the accumulator. Accumulator pressure indicator, I'll show you how it is. We just explain it, I'll show you. Pressurization with cargo door, pressurization with yellow pump. During parking brake, accumulator pressure for sufficient brake. Duration, how much is the duration? So I already answered it, it's 12 hours. And also you will see on the brake pressure indicator a green band which is showing green only until 1000. So what does that mean? I said no, more the pressure the better the strength of the hold. So why is there a green only up to 1000? Does it mean that above 1000 it's not correct? To find this answer is a homework for you. Please go to loss of braking procedure. You will understand why is there a green band. Oops, let's see the video now. Alright, you can see the brake accumulator pressure here. The indicator of the right brake, that is for the left brake. Maximum is 3000 psi. Currently it's close to 2000 psi. And you can see the accumulator needle in green. So everything is off, right? There is no hydraulic pressure at all, but accumulator is able to store that pressure. That is what it's there for, right? So that is what is now supplying the brake pressure. So let's see what happens if accumulator loses its pressure. Again, ignore that this button is in. No, yeah, now I fixed it. Let's see. If I keep operating the brakes multiple times, no, the accumulator will use this action a lot of times to pressurize the brake. See, I turned off the parking brakes. What do you see? Accumulator still has some pressure in it, but you can see the parking brake pressure has gone down to 0. There is no wheel pressure anymore. So keep doing this. What happens? See, pressurizing the brake is. So every time I do it, notice that the accumulator is losing a little bit of pressure. If I keep doing this, it's not correct to do it all the time like this multiple times, but let's see what happens. See, now it's saying brake yellow, accumulator low pressure. Why? Because the accumulator has used up all. Now it needs some system to pressurize it back again. It has lost all its pressure. The wheels are 0. So now even if you put the parking brakes on, the aircraft in a slope, it will roll. There is no pressure holding. So again, we will inform the ground crew. If you find it in your flows that this pressure is not sufficient, wrote all the ground crew, tell them that you have pressurized the yellow system once your clearance is received. Same way like before, see, the accumulator gets pressurized by the yellow electric pump. And the pressure is back. Now I put the parking brake again. Now the brake pressure is back to normal. So this is the normal way in which you pressurize your yellow accumulator. Alright. Now let's see another situation where the same thing. I depressurized the accumulator just to show you that low pressure situation again. Hope you are following all these things. Now the cargo doors are operating. So when the cargo doors are operating, the same thing we discussed before. See, this also pressurizes your brake accumulator. Remember, alternate braking is also get pressurized. See, when the cargo doors work, it pressurizes your accumulator also. Okay, so that is why in most cases you won't see this low, because when the cargo doors keeps opening, right? So yellow pump keeps running, and it's not very unlikely that the aircraft will be sitting idle for so long that it loses its accumulator pressure. So I hope you are clear with all your normal operations. Now the last part we're going to talk about is abnormals. This will be done in the second part of this.